Okay, 40, where are we at? 46? Reserve. How many lines of symmetry in the regular polygon below? Three? That's what you said? Let's see. Where would I draw the first one? Just straight through the middle like this?
No.
No? Or?
No, from side to side. Points.
Oh, from the vertices?
Yeah.
So like here's one,
Yeah.
and then here's one, and then here's one. Those lines would cut it perfectly in half, right?
That's good.
Anybody think of another line that might cut it perfectly in half? Laura?
Down the middle.
Right down the middle. Wouldn't this line here cut it right perfectly in half?
Yes.
Would it? Like this, right? And then like this. How many lines is that? 6. Let's go with 6. Anybody have any questions about number 46? Okay, 47. Oh, crap. Choose from the below reasons to complete the proof. Okay? So this is like matching or a big multiple choice question. See this proof we got here. The given part is angle 1, 2, and 3 are interior angles of a triangle, and an exterior angle 4. They want us to prove that the measure of angle 1 and 2 is equal to the measure of angle 4. We already talked about that in another problem, right? Because 4 is the exterior angle, and we know that if you add up 1 and 2, it has to equal 4, right? They just want us to prove it. Alright, so let's start with statement number 1. The measure of angle 4 plus the measure of angle 2 plus the measure of angle 3 is equal to 180.
That's right. Oh, no. It's going to be the 4 dimensional.
It can be like more than one. It can be like more than one.
I think it's supposed to be measure of angle 1, measure of angle 2, and measure of angle 3 is equal to 180.
Yeah, that's right.
Let's switch that. Switch this to the measure of angle 1.
It has a question mark next to it.
Switch it, change it. Is that what you did?
No. I
What'd you
kept
do?
that the same.
Huh?
So I kept that the same, but I put, for number 1, I put G.
Yes. But switch it to 4. I mean, switch this to measure of angle 1. How do I know that angle 1, 2, and 3 equal 180? How do I know that?
Oh, because a triangle is 180. The triangle has
All the angles, not a triangle, but if you add up the angles, which is G, triangle sum theorem. Okay? Measure of angle 1 plus measure of angle 2 plus the measure of angle 3 has to equal 180 because of triangle sum theorem. Okay. 3 and 4 are supplementary. How do I know that?
Oh, you know when we did the thing with the transversal,
Yeah.
and there's like,
There's no parallel lines here, so we don't need to be talking about transversal. Parallel lines, and then we talk about transversal. Yes?
Because they make a line.
Yeah, they make a line. What's another name for that?
A?
It's in the, yes, linear pair theorem. What word is in linear?
Line.
Good, I'm glad you didn't say ear, that would be bad. Linear, line, right? We know 3 and 4 are supplementary because they're a linear pair. 3 plus 4 equals 180. Definition of supplementary. D. We said they were supplementary. Well, now we know the definition of supplementary, so we can say they're 180. Number 4. This one might be a little tricky. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4.
I said E.
E? Is that what you said?
I said E.
E?
I thought it was flex.
Okay, look here. Reflexive. This pen equals this pen.
Oh.
That's reflexive. It's like you're looking in a mirror. You see the exact same thing. What do you think? No. Addition property says if I have two things that are equal, I can add the same thing to both sides and they'll still be equal.
That's symmetry.
We have to get this answer from what's above it. Everything that's above it, we have to get this. How did I get this from this stuff? Laura?
F.
F, substitution property. Look what we got here. Don't just write F and shut down. Pay attention. 1 plus 2 plus 3 equals 180, right? 3 and 4 equals 180. So can't I take this and substitute it in for this 180, since they equal this 180? So now I've got 1 plus 2 plus 3 equals, instead of 180, I'm substituting in this. 3 plus 4. Substitution is F. Now, how did I go from the statement number 4, to statement number 5? What did I do? What did I add to both sides to get statement number 5? What's missing?
The 180.
There's no 180 in statement number 4. The measure of angle 3, right? It's missing from both sides. So what do you think I did? I subtracted it. I minus measure of angle 3 to both sides and they go away, so I'm now left with that. So subtraction property. No, where is it? C. So now we proved exactly what they wanted us to prove. The two remote interior angles, 1 and 2, is the same as the measure of the exterior angle. Questions on 47? Okay, 48. Drew, this is your question. You brought this up.
Oh, yeah.
Oh, yeah. What do we call those two angles? The lines are parallel. The angles are never parallel.
Same side interior.
Same side interior, right? They're on the same side of the transversal, and they're both inside the parallel lines. Same side interior. What do we know about same side interior angles? They're supplementary. Same side supplementary. Yes? Same side supplementary. They're both, all three S's. Same side supplementary. Those are the only two angles of the group that we learned about that are supplementary. All the rest of the pairs that we learned about are congruent. Alternating interior angles are congruent. Alternating exterior angles are congruent. Corresponding angles are congruent. Same side interior, supplementary. What does supplementary mean? They add up to 180, right? So I can do 4x minus 5 plus 5x plus 5 equals 180. On the left-hand side, I can do what? Combine like terms. 9x equal 180. Divide by 9. X is equal to 20. Which value of x makes it two lines parallel? D would have to be, or 48 would have to be D, 20. Yes, ma'am?
I did mine a little different. I did the angle next to 5x plus 5, because that's complementary with the 4x minus 5. I just moved that over there and then set up my equation from there.
What equation did you set up?
5x plus 5 plus 4x minus 5 equals 180. But
So you added the two angles this way.
Yeah.
That's all.
I'm saying I took that one, I took 4x minus 5 and I moved it next to 5x plus 5. Cause,
Here,
yeah. Because there's.
this is also 4x minus 5. What do we call this angle and this angle? The two angles that are labeled 4x minus 5s.
Interior opposite angle or something?
Alternating.
Alternating.
Interior, right? So I know these two are congruent, and then what she's saying is she set these up like a linear pair and made them supplementary. Yeah? But we could, both ways it work. Either way, you're adding them up and it equals 180, right? Good. 49. Determine which of the below statements are true. All squares are rhombus. What the heck's a rhombus?
What's that?
We learned about rhombus? It's the plural form, right? Of rhombus, right? Yeah. Okay, so all squares are rhombi. Is that true?
Yes.
What's a rhombus? What's the definition of a rhombus?
Isn't that like 4 sides?
Quadrilateral, 4 sides.
Yeah.
So any 4-sided figure is a rhombus?
No.
And they're right.
Yeah, no, right there.
Is that a rhombus? No, it's not. That's a 4-sided figure, though. So what makes a quadrilateral a rhombus? What's the definition of a rhombus?
All sides with equal sides and three sides.
That's it. That's it. It's quadrilateral. All 4 sides are equal. That's it. That's a rhombus. So normally when you see a rhombus, you see that it looks like a diamond. Normally you see it looks like that. But this has to be all 4 sides congruent. That's the definition of a rhombus. Quadrilateral, 4 sides, they're all equal. So let's go back. All squares are rhombi.
Yes.
Yes. Everybody okay with that?
Yes.
Okay, so that one's good. All parallelograms are rectangles. Parallelogram. That's an example of a parallelogram. I could draw one like that, right? Parallel, 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 parallel. There's a parallelogram. Is that a rectangle? No.
Oh, I said trapezoid.
That's parallelogram. So, no. All kites are quadrilaterals.
That's
Kind of true?
That's true. That's definitely true.
What's a quadrilateral?
It's like,
All sides.
it's like,
And angles.
they have quad, four.
Quadrilateral. 4 sides. That's it. That's what a quadrilateral is. Any figure that's got 4 sides. Is there any kites that don't have 4 sides? No. All kites. It's a 4-sided figure. So all kites are quadrilaterals. Yes.
See,
We're not even going to look at.
no, because it's 2 and it's 2 and 5.
Well, let's look at it anyways. All trapezoids are parallelograms.
That's wrong.
Parallelograms, opposite sides are parallel, right?
Yes.
And if I draw a trapezoid, I could draw a trapezoid where the opposite sides are not parallel, right? This is not parallel to this. So this is not a parallelogram. So this. So it's got to be C. Questions on 49? All right. Kitty. Which type of transformation does not result in rigid motion? What's rigid motion? Rigid motion. If you don't know this, you're going to be writing this down. What's rigid motion?
Is it like
Sound like when it's moving, like, yeah, that's what it sounds.
It sounds like it's all messed up. It's like.
Moves it around, but what? That's the motion part, moving around here.
It's not.
What's the rigid mean?
On edge?
The shape does not change at all.
Oh.
So you can translate it, you can reflect it, same size shape, or you can rotate it, same size shape. You cannot dilate it and make it bigger. That would be not rigid, or make it smaller. So dilation is not rigid. Any questions? Okay.